All right, here we go. So let's talk about this right here. So what you're looking at here is one more addition to a two-step equation, okay? Your first rule is to move all the x's to one side of the equation. So I recommend going on the left because we always have the x's on the left, so let's just keep it a normal thing. So keep in mind that if you move something from one side to the other side, okay, its sign changes. So that's a positive 4x. So when I grab it and I move it over here to this side and cancel it out here, it is going to change signs. So I'm going to move this 4x over here. So I'm going to write 4x right underneath this. So now it's one of these, minus 4x's. Okay? Now that I've moved it to this side, this is now gone. You see how I didn't put it under the 6? Because those two can't combine like terms, and that would have wasted my time. So 8x minus 4x now gives us our brand new equation on this side, which is now 4x plus 6 equals, so this is now 0. So 0 plus 30 gives us 30 here. Now this is a two-step equation. There are two things happening to the x. You should know that you're getting rid of the 6 first because that's the last thing that's going to interact with the x. Because if x was a real number, like if I said x is 2, what would you do with that 2? Oh, I'd multiply with the 4 because that's the order of operations, and then I'd add 6. Okay, well, seeing as though you said add 6 last, that's the one you have to get rid of. And what's the opposite of adding 6? Subtracting 6. Whatever you do to one side, you do to the other. Bring it down, you're left with 4x equals 24. Then what's the opposite of multiplying by 4? Divide by 4. Remember, this is my division symbol. I do not draw this and use it, so you won't see it anymore. Divide by 4, divide by 4, x equals 6. Okay? So after you do this first movement, that's it. It's a two-step equation. If you know how to do a two-step equation, it's done. If you don't, I would say revert back to the other video that we have, the pre-algebra video on 1 and 2-step equations. Okay, so let's go to the next question. This is the next question. So before, now we have multiple things, okay? Now before we do anything fancy, make sure that there's only one x and one y on both sides. That should feel normal, okay? I'm gonna do the first step in red. So this has one x and one number. I'm fine with that. That's gonna come down. Okay? This has two x's and one number. That's not what I want. Before I start moving things around, I want it to look real simple. So what is negative 3 plus 1? Because there's one x there. Remember, there's one x there. So negative 3 plus 1. So I'm going to put negative 3 over here and 1, and it's a positive 1. And I'll put it right there. Remember that when you're adding, subtracting, the sign on the top, because that's the 3, that's the number furthest away from 0 is the one I always put on top. So the sign on top is going to control it. These signs are different, so these are going to subtract, so you get a negative 2. So now you have this is turning into negative 2, and then negative 2 x's. Don't forget, Mr. Kessers. And then 28 over here. Now it looks just like the one we just did. I'm going to move that 2x to this other side. I'm going to draw this line here so you're following along. This is step 2. All the x's go to one side. The minus 2x, I'm going to move over here. And what happens to the minus 2x when I move it over here? First of all, it turns into plus 2x. And second of all, this is no longer here. This is a 0 now because you moved it and got rid of it. So nothing's there anymore. So it's a 0. So now we're left with a new problem here and a new problem over here. This is going to make 5x. The plus 8 comes straight down because it's the only constant there. 0 plus 28 is still 28. Now we go to the next color, which is green. Now we have to solve this equation. So we're going to get rid of 8, okay, just like we did in the other one. 8's the last thing that's going to affect the x. So it's the first thing I'm going to get rid of, minus 8. We're left with 5x equals 20. Then these two are multiplying, so we're going to divide by 5. Divide by 5, x equals 4. Okay, remember, whatever you do to one side, you do to the other side. You're trying to leave x by itself, which is our end result. X is all by itself. 5 divided by 5 is 1x. How do you write 1x? Right there. Okay? So if you understand two-step equations, this red is the only new thing. I guess the blue because you're adding, but we were combining like terms in the two-step equations too. The only new thing that you're doing is moving one thing to the other side, and then it looks like a two-step equation the rest of the way down. Okay, this section, converting a repeated decimal into a fraction. Okay, so this 5 is going on forever, 0.55555 forever. Okay, now the way that you solve these, first you make 0.5 repeated equal x. Okay, or let's move the x to the other side, so then you guys feel comfortable. 0.5. Okay, pretty simple, not a big deal, Mr. Caspers. So, however many numbers are repeating in the sequence. So right here, the 5 is repeating forever. So one number is repeating forever. Okay, so you're going to multiply this problem by 10. If there were two numbers repeating, like 27, 27, 27, 27, 27, you'd multiply by 100. If there were three numbers, you'd multiply by 1,000. So how many numbers are repeating is how many zeros are going to be in this multiplication. Okay, so there's only one number repeating forever. So you're going to multiply both sides by 10. Okay, so what's this side by 10? 10x. What happens to this when it multiplies by 10? It's going to turn into 5.5, still going forever, Mr. Casters. You haven't done anything to this problem. I know. Okay, just wait. Now, you're going to write everything up here and write it again down here, right below it. So x and 0.5 repeated forever. Okay? So now we are doing a subtraction problem. Okay? What's 10 x's minus 1x? You're left with 9 x's. Now remember, these are the 5s forever. And underneath each 5 is another 5 forever. So they're just going to keep on 0, 0, 0, 0, 0. I'm going to subtract and go 0, 0, 0, 0. So what you just did over here with this step, with what's happened, is you've gotten rid of the repeated decimal. Now you're just left with 5 minus 0, which is just 5. Then, how do you leave the x by itself? You do the opposite, which it's multiplying by 9, so I'm going to divide. And x equals 5 over 9. Pretty simple, right? Okay. Now this one here, convert 0.26. Okay. Again, same rule. Everything is going to be the same. I'm going to make x. I'm going to do every step in a different color. So we'll start with red. So first thing is to write x equals 0.26, exactly the way it is. So that's the first step. Second step, in blue, you're going to multiply both sides by a number, by 10, 100, 1,000. It depends completely on how many numbers are repeating. Now, the 6 is the only number repeating. So there's only one number repeating over and over again. So we're still multiplying both sides by just 10. So multiplying both sides by 10 will give you this. 10x equals 2.6, and this is still repeated forever. Okay? So 2.6. Now, you're going to put everything here underneath. So that would be the third step. The third step would be to just repeat this line of information underneath. So x equals 0.26 forever. Now I want you to remember that the 6's are going on forever. A lot of people accidentally put a 0 here. There's no 0 after the 6. The 6's go on forever. So if you have to fill in a space here, a 6 goes there. Because remember, these 6's are repeated and going on forever. That's a tricky one. That's why this example's here. So now we're going to be subtracting all the way down. So this would be the next step. So you're actually subtracting. So now you're going to be doing, so let me write that minus in here. So then you see that it was the next step. So now we're going to do 10x minus x. That's going to leave us with 9x. This is, now remember, the 6 is repeated forever, so those are gone. So those are gone. The repeated 6's forever are gone. Now it's just 6 minus 2, which leaves me with 4, and 2 minus 0, which leaves me with just 2. Divided by 9. Okay, divided by 9, divided by 9. Now this is a correct answer, but decimal points aren't allowed in a fraction because fractions represent decimal points. So we're going to move this decimal point over 1, and we're going to do the same thing to the 9. Okay, so the answer for this one is 24 over 90. Okay, that is a correct answer, but I do want you to try to simplify 24 over 90. Okay, they're both even numbers. When they're both even numbers, meaning they end in 0, 2, 4, 6, 8. So if they're an even number, you can cut them in half. So that'll shrink down the number so then you're not freaking out. So here we'll have 12 and 45. These are both divisible by 3. Okay, so this will still make, I'm going to divide this by 3, divide this by 3. If you're wondering how I got 1245, I cut these numbers in half. So that's going to give me 4 and 15, and now we're finally at the right answer. Now this is fine with me, but I want the effort. So you have to show me your work. So if I see this, I'm like, oh, he got it right. Let me see how he's doing with this, or she's doing with this. So that would be the next step. We're still good on time here. Okay, now we're doing this. Convert 2.09 to fraction form. Same thing. Now we're turning into a fraction. So we already know the fraction starts with a 2. Okay, so we don't have to do that. We know that the fraction is going to look like this 2 and something here, something here. So we're going to ignore the 2 while we're doing this. All right? Now, the first one, we're ignoring the 2 because we already know the fraction looks like this, 2 and something over something, right? So we're figuring out the something over something. So we're just going to write x equals 0.09 with this little line over it. Remember, the 0.9s are repeating over and over again. This has 2 numbers repeating, 0.9, 0.9, 0.9, 0.9. So we're multiplying both sides by 100. So we're going to be left with, the next step I'm going to do in blue. We're left with 100x equals, move the decimal point twice because you're multiplying by 100. So now it's just 9.09. Remember, everything after this is still 0.9. So when I move the decimal point over, there's a 9.09 there, okay? So now this is my end result. Remember that this is repeating forever. Then we are going to grab this, put it underneath. So that'll be the third step. X equals 0.09 repeated, okay? Then the next step is now subtract them. So subtract. You're left with 100 minus 1 is going to be 99x equals, you subtract here the repeated decimals, okay? So these are gone, no more repeated decimals. 9 minus 0 is just 9. How do you leave this by itself? X, you divide by 99, cancel, divide by 99. So now the answer is, I don't like how close this is. The answer is x equals 9 over 99. Okay? If you haven't noticed, they're both divisible by 9. Okay? So I'm going to divide them both by 9. This is a correct answer, but if you divide them both by 9, you'll get 1 over 11. And that's your final answer if you're simplifying. Okay? Now, for this last thing, I only have like 3 more minutes before the bell rings and we go to the next class. So I'll erase this stuff here because this line kind of got in the way. Now, rational and irrational numbers, or irrational numbers, okay? Remember, irrational numbers are numbers you can't explain to another human being, okay? If somebody's standing across the room, can you explain the entire number to that person so that they know what it looks like in one view in their head? So that's what you're looking at here. So, pi goes on forever, okay? And it just never repeats. It goes on forever and never repeats. So if you were going to tell somebody this number out loud, you'd be talking forever. So you cannot explain to them this number. So pi cannot be explained to another individual for them to grasp the entire number, which means this number is irrational. Okay? Now this one, 3.56, 556, 556, okay? It didn't repeat here. It kind of is repeating here, but I was supposed to put another 5 here to kind of get you. Oh, there's a pattern. I see it, 556, 5556, 55556. You'd still be talking forever to someone because you don't know if it continues like that. It has to be considered, I don't see a line above it telling you that it's repeating over and over again, so it doesn't repeat. So that means that over here, there's a 3 somewhere or a 9 that you didn't know about. So again, this number, even though it has a cool pattern to it, it's not repeating over and over again. So this, again, you cannot tell your friend what this looks like. So this is still irrational, okay? What about this number? Same thing, still irrational. Still irrational because look, there's no pattern to this. There's no line above there telling you it's going to repeat forever, okay? That means that it's irrational. I cannot tell someone what this number looks like in its entirety. This one, I can tell my friend, negative 17. Oh, okay. I know what that looks like. Cool. So that's rational. So any number, any whole number, any negative whole number, they're all rational, okay? Because they're numbers that you can explain to somebody else easily. This one, 0.76, it's a decimal point. Well, I can still explain to somebody, hey, it's 0.76. Okay, cool, I totally get it. Okay, so that one's acceptable as well. So that's also rational. What about this? This has 3 decimal points. Well, let me try to explain it to somebody that's not on camera. 3.275. Oh, okay, yeah, I totally got it. Got the whole number in here, whole thing. That's also rational. Even if I write 3.8, oh, look, the 8's repeating forever. How are you going to explain that to somebody? Well, it's 3.8, and then the 8 goes on forever because it repeats. And that's what the whole number looks like. Oh, okay. So any number, anything that repeats forever is also rational. Okay? What about a fraction? You got to figure out the fraction to figure, no. All fractions are rational because the definition of rational is it can be made into a fraction. So because I can explain to you, what's this number? It's 2/3. Oh, okay, thanks. What about this negative fraction? Negative 5/7? Yeah, it's negative 5/7. Oh, okay. So this is also rational and this is also rational. Rational numbers are a number that you can explain to somebody else and they know what the entire number looks like. Okay, this one, even though they can't see it, you can tell them, hey, the 8 just goes on forever. They know what it looks like. Here, you don't know what's happening beyond this point. There's no line telling you it's repeating. That's why these are irrational and these are rational. And that's it.